Hello, everyone. I hope you are all safe and well out there. I'd like, first of all, to thank the organizers for the invitation. As the title indicates, this presentation will give you a quick overview about top 5 main security concerns in a blockchain as a service environment. The blockchain, I think, nowadays is a hot topic, and I think most of you have an idea about it. But in a quick reminder, let's refresh the memory. The blockchain is considered as a trust machine or as a technology that digitizes the trust, enabling, for instance, anonymous people to exchange Bitcoin without the need for any intermediary. So blockchain basically is the intersection between 3 components. First, a peer-to-peer network where a new service provider is present. The second component is a consensus mechanism that ensures the validation of transactions and ensure also the agreement amongst the entities of the peer-to-peer network. And the third component is a special ledger or database that stores the validated transactions. This ledger is special due to its characteristics, since it's tamper-proof and append only. So once data is added, it lives there forever. And the blockchain enforces this by adopting a special data structure where transactions are added in each time window in collections, or what we call blocks. So typically a block is just a logical entity, and these blocks are linked between them. Each subsequent block includes a pointer with just a simple hash to the previous block. And the benefits of the blockchain are huge, and I think you are all aware of them, mainly for businesses, because blockchain can help businesses to reduce time and cost. So due to this growing interest, which we can consider outside the cryptocurrency sphere, many types of blockchain emerged since the first blockchain, which was, of course, the Bitcoin blockchain, which was launched in 2009. And then we evolved toward consortium and private blockchains. And we end up, or we extended these toward what we call blockchain as a service, which is basically a category of cloud computing service that provides a platform allowing customer to develop and manage blockchain application without the complexity of building, without caring about the complexity of building and maintaining the infrastructure required to build a blockchain-based project. So currently, we have almost all cloud providers that offer a blockchain as a service. So in a typical Baas solution, blockchain as a service solution, resources are isolated in a private virtual network, as is shown in this picture. So we have usually a private virtual network, and each transaction and validation node is a virtual machine. VMs in one virtual network cannot communicate directly to VMs in different virtual network. This isolation can ensure communication to remain private within the virtual network. We have also, besides this this virtual network, we have usually a load balancer. So a load balancer helps to maintain high availability, and we have also network interfaces, which provide a means for communication within the virtual network and between the customer implemented clients. Also, the load balancer exposes some number of endpoints like RPC points, SSH points, or HTTP points, allowing requests to be submitted and executed in the network. And we have also another component which is the redundant storage. So we have this redundant storage is needed particularly by validating node to store the ledger Also, we have usually a membership service assigns users, groups, and application rules for blockchain members and node access. So this, in a nutshell, the main component in a typical Baas service. So it's good to know this architecture like this. We can understand what are the concerns that will came later. So the 5 security concerns, we will start with the simplest one. So there's a potential compromise of user keys, because we know in blockchain we use basically an asymmetric cryptography algorithm. So we have always this peer private key and public key pair that should be generated, and usually the private key and public key pair is stored as a file, an encrypted file, of course, using a password, a passphrase. These keys by design are generated at the node level. So in a simple Baas case, they will be stored in the VM which is running the blockchain client. Therefore, any attacker who gains access to the node VM can easily pick up the keys and therefore control the wallet, and he would be able to perform any actions he wants. So the solution would be to use some secure key vaults, especially some HSMs, which makes it impossible for unauthorized users to extract these keys, and therefore the system would be more secure. The second concern is potential compromise of the membership service. So in a blockchain as a service environment, we usually run permissioned blockchains, so which means only authorized users can access and join the blockchain. That is, the authentication and access control is ensured by a membership service. So a compromised membership service will allow unauthorized nodes to join the network and synchronize shared data, which will be a real problem, opening the door to civil attacks or data breaches. So to solve this problem, blockchain architects should choose a secure authentication service to provide strong identities and strong authentication. The third concern is vulnerable built-in templates. Normally, to make blockchain, the blockchain adoption easier, many Baas providers offer blockchain deployment templates. These templates provides the needed configuration to run a blockchain network. However, vulnerable templates, either a vulnerable configuration of vulnerable resulting tools can compromise the entire blockchain security. And usually these templates do not prioritize the security. So you can end up with a duplicated insecure version of blockchain client or insecure configuration settings. In this case, it is advised to avoid the default configuration settings provided by these templates, or also in the documentation, and use some secure personalized configurations. It is also advised to examine the templates configurations. You should not use them as the same with the vendor. We should also, once the blockchain is deployed using these templates, we should try to update the tools that were installed and check if there is any security problems. So the fourth concern is the misuse of RPC servers. So generally in the blockchain as a service, there is RPC interfaces that allow us to execute commands on the blockchain clients. For instance, sending transactions or create accounts. So misuse of the RPC server, for example, by opening it to the public access, can, without, of course, a correct firewalling, can enable attackers to remotely execute scripts on the blockchain node, okay, and therefore they can gain access to sensible data or execute critical actions. So to avoid this, it is very, the blockchain architect should be very careful when he enables the RPC server and bind it to a public address. So the rule of thumbs in some way it's to use always the RPC servers just for local testing or local development without use it in the production. So using RPC over a public address is a kind of it's a bad choice. And beside that, the developers or the blockchain architects should avoid unlocking accounts for a long time, should use some control access mechanisms that last just for a short amount of time to avoid what developers tend to do, which is using or unlocking accounts for a long time just to make their development and test easier. So the last concern is enabling critical APIs. This is a related issue to the previous concern. So when you are using an RPC server, of course, with a good firewalling, it's always a good habit to disable critical APIs, APIs calls, of course, like calls that enable anyone to create accounts or backupping keys or whatever critical actions. So the blockchain architect or developer should or allow just the APIs that are needed for the application to work. So they should avoid any extra API that there is no real need for it. And besides this, it is good to use signed transaction with REST API instead going directly for an RPC server. This in a nutshell, the recommendations that we are giving to developers, because developers tend to underestimate security. Their main concern is to make things work. And in blockchain, this is a very, very sensible problem, because if an unauthorized person has access to any node in the network, he is accessing the data that comes from other nodes, even if they are secured and well protected. So we try to help developers to avoid bad practices and to make some good design choices. So this was the last concern. As I've said in the beginning, my presentation will be just very, very short. So if there is any questions, I will be glad to take them. So thank you.